So I've got my lovely Alexa.
This is super impressive. I
Thank you.
Excellent.
I had a lot of fun doing that. I had a lot of fun, and now I'm into the parser, which is rather more difficult.
Right. So now we're going to write some code, and I might possibly put like a video. I might split the video.
Yes, because I'm aware that I've really rambled on.
No. That was really fun stuff. But now we're going to write some code, so it's going to change. We're going to change tone.
Okay. So obviously the parser is different because we can't just monotonically go forward. We've still got an iteration process, but we're producing now an AST node, and that may be built up from one or more of the tokens that we've got from Alexa.
Right. Yes, but I mean that's also true of the Alexa, right? The Lexing tokens can be built of one or more characters.
But we're representing them in a different way. Mm-hmm. So the Alexa token is, let's say when we're Lexing, we go, oh, there's a double quote. We're Lexing a string. We just go along the string until we get to the quote at the end. Mm-hmm, mm-hmm, mm-hmm. With a parser, we can do the simple ones. Mm-hmm. Here we are. An empty input produces nothing. That's easy.
Yeah, we can do that.
There we go. We can do that. A number is parsed as an expression. Mm-hmm. And so we're gonna say, and so we're already introducing some rules of our cell grammar here, which is a number. Everything has to be semicolon terminated, right?
Yeah.
So for here, I'm expecting one little AST node, which is that, and it is an expression containing the tuple number 56. A string is also parsed as an expression. Yes, there we are. So again, I've got a string and a semicolon, and again, it's a length of 1, and the expression is the string.
By the way, you might prefer slightly different syntax for that string to avoid the escaping.
Oh, okay. Yes, please.
So before the double quote, if you put r#.
Oh, okay, for literal.
Yeah, and then after the close quote, you put a hash. The final one, I mean. No, leave the double quotes.
Right. Leave the quotes in, and then do that.
Yeah, exactly.
Yeah. Oh no, whoop, that one.
And then
I can do that, can I?
Yeah.
Oh, lovely. Well, let's give that a spin.
And that's like multi-line strings and things as well. So.
Okay, so what do we call that? What is that? Has that got a fancy name?
Literal, I think. I might be wrong there, so I apologise if I've polluted your commit history.
There we go. Lovely.
That's good commit discipline. And by the way, you can use as many hashes as you like. So if you have hash string inside your string, you can just
like Ed
do more hashes.
Right, but the next. Hang on. I was just taking out. What have I done? Oh, sorry. I'm using this MacBook that I throw Linux on, and every now and again it goes a bit funny. That's why the fans are running. Right. Because it's just feeling. So at the moment, I've also got an error case here. So we have to semicolon terminate the thing.
Yeah.
So that's going there. But the next test is
yes.
Hang on.
Where it gets interesting.
Over here is where it gets interesting. So hang on. Oh, sorry. Find it. Where's it gone? Got to look at the right window. I've got a window off the screen here. There we are. That one there. Oh dear. Tests. Test is. Okay, so this is the JavaScript. Sum of numbers is parsed as an expression. So, that's right, isn't it?
No, you want hash square bracket.
Hash thing. Yes, that's it.
Yeah.
Hash is that. So we'll say some. And this is what I was meaning about it getting more complicated, because when I see now a number, it's just the start of an expression, but actually, and the operation is in the middle, but I want the thing that comes out to be an operation that contains the number and the next number.
Yeah. The relationship between the input and the output becomes more complicated.
Yes. So let's say, and I don't know, I mean, I could look at how I did it in the JavaScript, but that feels like cheating, and I don't want to. I don't want to cheat straight off. 32 plus 44. I did like, by the way, or I do like that thing of yours where you're saying, I want the using different test data each time.
Right. I found a few bugs by doing that.
Yeah. So that's got to be 1.
Yeah.
No, I've got it. It is right.
Need an unwrap or something?
No. Oh, yes, I do. Sorry. Yes.
The test above doesn't, because it's an error, yeah.
Because it's an error, that's right. So that goes there. And then, I don't know what this is going to look like yet, so I think this is going to be...
Yeah. This is why test-driven development's so good.
And that's going to be... it's going to be an operation.
Yeah, are they going to be tuples, these abstract syntax trees, or?
Well, I started up here with an enum somewhere. There we are.
Mm-hmm. Right.
So I feel like I'm going to have something like an operation, and that's going to have. It's going to have an opcode.
Yes.
Let's call it that. Which is a char, maybe?
Maybe.
Well, I don't like what it's feeding me here.
I think it's correct. I'm sorry to say.
What's a box?
So, a box is an owning pointer. So, effectively, it's a pointer where you own the thing that you point at. And what you would like to have here is left-hand side is an AST node and right-hand side is an AST node. But
yes.
at that point, the compiler doesn't know how much memory your type will take up because it's recursive, so it'll be like infinitely large. So you have to have a pointer. So a box is essentially saying a pointer to an AST node that I own.
Oh, bum.
Yeah, it's sad. It's a bit sad.
Yeah, okay, yeah. The stupid thing is, right, if I'd been writing this in C++ and I'd made that like a reference or a pointer, I wouldn't have thought twice about it.
Yeah.
Because I'd know I need the forward declaration because I'm using it internally. But it just is okay.
Yeah, so I actually think that's one of the things I really love about writing Rust, that I find myself not making pointers most of the time, and I know that my memory is therefore nice and close together and cache friendly and whatever. But in this case, there's no avoiding it.
No. Okay.
So this all leads me to ask what the thing on line 12 should be called.
Fair. Well, I was guided by the tests that we previously wrote, Andy. This is your past choice looming up from the past. String is parsed as expression.
Yeah, so
that comes directly from that.
So it's my fault.
It's nobody's fault, Andy.
Yeah, so I think I'm using expression there to mean like AST node, basically.
Yes, possibly value, actually.
Yeah.
We can revisit this.
Yeah, okay.
But it's what's come out of the test.
I had real trouble naming this thing in Milk, and actually, my friend John said to me, like, I don't understand where you've got this thing. Like, he basically thinks I'm going to eventually get round to renaming the thing that I had, which is equivalent to that. I think it's like a leaf. Yeah, I called it a leaf, and so I think I'll come up with a name for this thing. Anyway, okay, go back to what you're doing.
Yes, this is all a little bit wordy, but I think I'm maybe I need a. Can you have function overloading in Rust?
No,
or not. Okay.
Can't even have variable number of arguments, which is why macros appear quite often.
Oh, for God's sake. I think it's because I haven't done make operation yet, so I think that's why the indentation is going peculiar. Okay. Make expression, make token. So we'll just write this out longhand. We'll come back and neaten this up later. I did start doing a kind of table-driven thing for this, but then because the results are more complicated, it got harder to think about.
Mm.
And then I thought, well, if I had a syntax for the AST, then it was all.
Yeah, that would be cool.
Right.
Maybe you could use use cell syntax. No.
Didn't you do that?
Wait, you can't do that because then you'd be testing your code using your code, right? But
didn't you start doing cell in cell?
Oh yeah. I started writing cell in cell, and I rapidly learned how awful a language cell is to write code in. So I would love to do that someday, but realistically, to do it, you would need compile errors that are not utterly impossible to understand. So it would take a bit more work, I think, before you could realistically do it.
Sorry, go on.
People do write like complicated programs in very difficult languages, but I found it too difficult.
In these functions here, can I... Oh, hang on, why don't I just do it instead of asking you? Can I specify that is actually going to be an expression?
No.
Yeah. Why not?
Because there's not a type.
It doesn't seem to be complaining.
Well, I think it's confused by your later compiler, I think.
By the later compiler error.
Like, I have wanted this, so if this works, I will be very annoyed.
Okay, let me type this one here, and so the operation, and then I'll just pop. So right, okay. So opcode. Oh, sorry, it's me touching the touchpad. Opcode. How do I create this box nonsense then?
Box : new.
And then I just give it the thing that it's boxing?
Yes. And it just takes ownership of it. The beautiful thing about the move semantics in Rust is that they just work.
And this, so this is a move?
Yes. And potentially you could be moving from the stack to the heap. It will just do it, I'm pretty sure.
Well, we'll find out. Is this in this enum initializer here? Is that is it a comma here?
Yeah, but you need like LHS colon and then the thing, because it's a struct like thing.
Because it can't match. So I like that.
Yeah, exactly. Because you got this. The first one is just a shortcut, but
just
syntax.
Right, but here I need to do the thing because otherwise it doesn't know what the right. Okay.
Yep.
Okay. So, well, let's see what happens if I put operation on the end there, because that feels like a contravariance thing, right? It is an AST node, so I can still assign that to an AST node, but it's a tighter type. Is this?
Yeah. I'm
right?
pretty sure this doesn't work. Is it?
Oh no! Hang on. Oh, that's my leftover JavaScript. Yes, you're right. It hates it. There we go.
So I would love
Never
this.
mind.
And actually, there is a pattern that people use sometimes in Rust, which is quite confusing. But the reason for it is basically this, which is in that AST node enum, each variant would just say operation brackets operation, and then you would define that struct operation somewhere else, and now you've got both a type and an enum variant with the same name and approximately the same meaning.
Right. Sorry, here's me not calling the function that I just created correctly.
Yeah.
So I wrote it like it's Ron Jeffries calls this programming by intention. So you write the function you wish you had, and then you implemented it. And I wrote the function I wished I had, and then implemented it differently.
But yeah, that's definitely the way to code. Definitely.
Lovely. Well, look at that. That's compiled and
nice.
Not worked. Yay!
Yeah. So just to revisit your thing, because I do think it's interesting. If you go back to the AST node enum,
there we are.
Yeah, for operation, if you made a struct just above called operation, and then on line 13 you just said operation round brackets operation, outside of here, like somewhere like just above line 10.
Oh, I see. Sorry, above up there.
Yeah.
If you I don't know what's happened.
Your poor markets.
Operation.
So if that struct had that like opcode left-hand side, right-hand side stuff inside it.
Yeah.
And then on line 15 you just said operation round brackets operation.
Oh, right. So the things in the enum can... Oh, okay, right. Yeah, I see what you mean.
Then that's the way people kind of work around what I see as like a weirdness of the way enums work, which is that variants are like values you can have, but they're not a type, and you often want them to be a type because you know which variant you've got.
And I've got a feeling that they are types in some other languages, right? Or they act more like types.
Maybe.
Right?
I don't know how this works in Haskell.
Because this is an algebraic type, right?
Yes.
Is this right?
An enum is an algebraic type. Yeah.
And is an algebraic type the same as a discriminated union?
I think it's implemented as a discriminated union.
Right. I still don't understand any better, but I thought it sounded like an intelligent question to ask. This, on a more practical note, when I first wrote my assert macro, it said, I can't work out if they're equal or not because it doesn't do partial equal.
Right.
Put this magic incantation at the top. And then it said, I can't do partial equal because you don't do debug. Or the other way around. I forget which one it was. So I put that in and then it works. But what magic is happening here?
This is yet another one of the really amazing bits of Rust, which was directly stolen from Haskell again, like a lot of things.
Okay.
So basically, this is actually there are macros behind this. So someone has written a macro which when you say derive partial eq, it generates a bunch of code which is like an impl block for AST node, saying impl partial eq for AST node, and it provides all the code of that implementation as well.
By introspecting on the struct itself to generate the right things for the members of each.
Yes. At compile time.
Right. Gotcha. And debug then is just making it look nice when it's in...
Debug provides a some code that provides a like pretty print of the contents of this thing, again by introspecting at compile time.
Okay, and the one is relying on the other then, presumably.
No, I think it's the assertion. You can't assert things unless they're debugged.
Right. So the assertion needs it in order to give you a nice looking error message if it all goes wrong.
Yeah, but there can be dependencies like what you were expecting there.
Right.
But that one isn't one, I don't think.
Lovely, because otherwise I'd have to actually implement the
Yeah.
comparison operator or whatever.
This is so good. Like, and there are amazing things like default, which gives you like a method called default, which makes an instance of your struct with all with the values filled in as defaults, if that makes sense for your struct.
Right. What is the default value of a thing in Rust?
Well,
or can I not do that? If I declared a member, do I have to initialize all my members when I create
you do have to initialize them unless they implement default, in which case you can implement default and it doesn't.
Well,
and so if you do derive, you can manually implement default and then specify what the default is, or you can derive default, which will implement it for you, in which case it will guess like numbers come out of 0 or that kind of thing.
Okay.
And also, by the way, the serialization, which is massively used in Rust, which is not part of the standard library, but is like almost as important as the standard library, is this crate called Serde.
That would be my guess.
Yeah. And so Serde has these similar derived macros which generate you all the JSON creation code you possibly need just from your struct definition. It's amazing.
Gotcha. Right. Good.
Let's make this test pass.
Let's make this test pass. I feel this is going to be quite tricky now. Okay. So that's what we're looking for. We're going to get 4 Lex tokens coming in, but we're going to throw the one away. First one that comes through is going to be a number. So, right. Here's my minimal implementation. My next node.
Mm-hmm.
So, this is doing absolutely the minimum it can to make everything else pass. So, we say we've got the next token, and if we get a next token, then we make it into an expression. Otherwise, we're at the end. And the next token says, okay. Oh, right. Yeah, this is a little tri-state thing that I was talking about before. Look.
Right.
So we haven't actually got to any lexing errors propagating through the parser.
Right.
But I assume what happens when I hit that to do macro is that it just explodes and says you haven't done this.
Yeah, that's a runtime crash, basically. The panic.
That's lovely. We'll look. A panic. Oh, that's very retro. Okay. So
by the way, you can catch panics, but you shouldn't.
No, I don't. No. If it's a panic, it's a panic, isn't it? And then, my next expression is I've got a token, and all I'm doing is making it into an option, and then I assume the next token is a semicolon.
Right.
And if it's not a semicolon, if it's not a semicolon, I must have just run out. So this is really like proper TDD, because there's nothing in here that doesn't satisfy the tests.
Yeah, that's the way it should go.
So,
and you shouldn't do any error handling until you've got a test that checks that you handle errors.
Okay.
So where do we need to write the code? Is it in next expression or next node?
Is it in next node? Well, we need to not return.
Yeah, we need to grab an expression and then check whether there's any more.
Okay, help me with the matching here.
Uh-huh.
Okay, so this thing here is returning this. What's coming out of here is this option with this token
tuple.
tuple. Token tuple. Sorry, I will.
No, I'm
update
sorry.
my,
I can't help it.
No. I used to say tuple, and then I heard somebody British saying tuple, and I thought, oh, because until then I'd only ever seen it written down. You know.
I have no. Yeah.
Oh, it's Fanshawe. Oh, right.
I can't pronounce half of English. I've just seen it written down, so I don't know.
Can I? Okay, let's just hang on. I'm just going to inline something horrible here. Maybe you can help me. So I've got my token, right, which is this pair. There we are. Can I match on part of the pair, or can I say if the first part of the how would I?
So
go about
it's a tuple, right?
Maybe.
It's actually so you can just do bracket and then put in what you're expecting, and on the other side you can do comma underscore if you want to.
So if I had something like, I'm going to have to make these into. So I could do something like that.
Yes, although it might not actually work for a string literal, but we'll see.
Yes. Oh, this was the other thing. I couldn't work out how to define like a constant.
Yeah, so I think you might want to stop using string literals and start using an enum maybe in your token tuples to make this easier.
Okay.
Maybe, but we could try this. I'm not certain that this doesn't work, so we could try.
Okay.
How far we get.
So it's.
No, definitely can't do that. Can't do that. Is it a string?
It is a string.
Okay, all right. So in that case, in order to make this work, we're going to need to take a reference to the string inside it. So you probably want to do like token bracket 0 in the match line. No, in on line 25. The thing you're actually matching on probably want.
Okay. Oh, right. Okay. Oh, I see. Okay.
And then do an ampersand on that maybe to get it.
Right.
No, again before token. Or no, in fact, you probably want to do astra on it after the 0.
Like that.
Probably now, if you can match on string literals, this should now match, I think.
Oh no, it's that, isn't it? Oh, okay. Oh, look at that. Maybe.
Now that compiler.
I'm gonna have to throw something in there, right, just to make it feel better.
You need a comma at the end of the previous line.
Yeah.
Right.
It hates it. Consider using a semicolon.
Use a semicolon after the whole statement, mate.
Use the comma, the question mark operator to extract the option value, propagating an option none value to the caller.
I think it's just saying you haven't finished your match. The match doesn't end with a semicolon. I think that's what it's saying. And
type editor. Right, that's fine. So okay, that's interesting. Okay, so right. I was just thinking out okay, so I can do that. So I can break down things in that.
If it was an enum, that would be a lot neater, right? Like you could say, you could just match and say if it's a semicolon.
Just match on the thing. Okay. Let's see if we can just smash our way through this. Anyway.
Make sure not to write good code. Just make the next test pass.
E. I'm running out of words now.
That's all right. If you just think for a bit, that's okay.
No, because I want to. Let's try this.
Right. Okay.
Try this. And that's going to be a mute self, and then that's going to be the token. and that'll be that, and we'll make that into an, I don't know if that's an option or an AST. Let's just call it an AST for now. No, it's an option AST. I like that. And then I'm just going to take that and pop that in there, because then I'm kind of, like we were saying about as soon as we start doing something in the Lambda.
Yeah, similar.
And
here,
so
yeah.
that'll be self build node token. Okay. And so that, oh right, what? How's that got
You've
there?
somehow ended up with an extra curly bracket there.
I have, haven't I? Lovely. That's the same one as before. Beautiful. Hang on, let's turn off. Let's turn off the good ones. There we are. Lovely. Right. So. I think this might be where we get your if let mute thing. If let node equals no.
You can't help yourself.
Right.
This is where you really get into trouble, because when you've got closures, suddenly life gets very much more awkward about the ownership of things like self. This is nice.
All right, everything's going to go wrong now.
Yeah.
But that's okay. Why is that not what does this need to be a reference?
You haven't passed it into build node, right? Oh no,
passed it into.
I see what you mean. What's it complaining about? What's it complaining about? Oh yeah, it needs to be some node, right?
Oh right, because it's unwrapped it for the and then.
Yeah,
so in that case, it just needs to be a different thing.
But you don't
right?
want to do this if there's nothing in it, do you?
Which is the one that doesn't unwrap the sum?
That would be map. No, would it be? No, that's the opposite. Sorry. I don't know. But are you sure you want this?
Oh, yes.
Okay.
Yes, I am. Okay. All right. I'll just wrap it up again.
There probably is one, and actually, if you go to the documentation, even if you built it locally and it's running in your browser, if you type into the search box the function signature that you're looking for, it will list the functions that match that signature. Just like that that cool Haskell thing that the Haskell kids had like 30 years ago. We've now got it too.
And right, so this is probably going to go disastrously wrong. Boom, everything goes wrong. Great, because build node, right, match token, first part of the token as what did we say? Astra.
Yeah. No, it's done as ref for you. I don't know why you wanted Astra.
Oh, yes. So what we're doing is we're building an expression. I think this needs to change. We'll come back to that in a minute. We're building an expression, and then we're chucking it back into the next node, and then we're going to try and do something clever. So if the next token is the semicolon, then we return the AST node that we just had. Oh, sorry. Your video's family friendly, Andy. I was in a hockey coaching workshop last week, which is I coach adults, but there's a lot of emphasis on coaching children. And we got put in a Zoom breakout room, and then I pressed the wrong button to come back into the main thing, and I swore very loudly when I realised what I'd done. But fortunately, as I came back into the main room, my mic had been muted.
That's a smart Zoom feature.
So otherwise it would have been quite embarrassing. Otherwise, again, this is why it's otherwise so that's the wild card, isn't it? Otherwise we'll throw everything into the next thing. Is this making sense, or have I just gone mad?
I think that might eventually make sense.
I think I'm doing that thing where you said about you can code golf this a bit hard. I think I'm code golfing a bit hard. Where's my next expression? So the next expression is, so I just actually here. I just want to get rid of that. And then I think we might want to keep that line and put it in somewhere else. And then we want to get rid of that because we don't want to consume any more tokens while we're building the expression.
Right. Okay.
Right. So next expression is the wrong name now.
Right. Yeah. Yeah.
And I think if that should be, if I'm expecting a token and I don't find anything, that's when I've hit the end of file.
All right. So so
confidently.
You hit the semicolon, then you return from build node immediately. And if you don't hit a semicolon, you're going to hit this line 25, and that. So
let's think it through. So in our first case, we peel off the number, and we pass it into build node, and we build an expression from it, and then we recurse back round into here. It's tail recurse, very functional again.
Yeah.
And we peel off the next token.
Yeah.
And that's a semicolon, and then we return the number.
So hopefully your other tests will still pass then.
Should now pass.
What will happen with your next test? It will end with just the last number.
It will return the last number, yes.
Okay, confident predictions from both of us.
Absolutely not. Oh, okay.
Empty input produces nothing. We're definitely not handling that case.
Empty input produces nothing because okay. Well, let's just bin out that for the moment and see what happens there. Ooh,
it's better.
Surprisingly better.
But actually, empty input is kind of a special case.
Yes, it is. But we got errors for everything if otherwise, didn't we? Why did that happen? Because even when we get to the semicolon, we might still have some more stuff, right? Because you can have multiple statements in the program. When we get to the semicolon, that's not the end of the program. So we call next again, but now we're at the end of the iteration.
Do we? I don't understand why we're failing now. Because when we hit the semicolon, we stop, right?
But the failing test case is missing semicolon is an error.
Yeah. So we're doing the right thing now. I agree that like when we have multiple statements, this isn't going to work.
Okay, let's park missing semicolons and error for a minute, and let's go for the sum is the number of paths. So that is giving us the last number.
So we were completely
so we were fantastically correct. So there's our plus. What are we doing here?
Question.
Do we? All right. So we've got our number in Prev, and then we're sitting on our plus.
Yeah.
So we want the next token.
Yeah.
So we want something like maybe I don't want to build. Maybe I'm just going to say operation plus prev self next expression like that.
Sounds about right. Might need some boxing.
No, not next expression. Next
node.
Node.
None.
And there's
maybe.
Maybe. Okay. Okay. So. Oh yes. You see, it's really easy to comment on people. You know, it's why I'm talking to your videos, Andy.
Yeah,
like,
Andy.
And especially when sometimes you're searching your code, and I'm going, it's right. You're scanning it.
I'm code blind.
It's there, Andy. It's there. Okay.
There is a level of panic when I'm coding on being recorded. That means that.
Okay, so these aren't boxes when they come in here. These are AST nodes, right?
Sounds fine. Yeah.
We haven't boxed them at this point.
Yeah, I feel like at some point we're going to go back and there's going to be a load of turning things into boxes of AST instead of concrete
probably.
AST nodes, but we don't need to do that now.
Okay. See, I've done that. Right. Yeah. Okay. So this is where I said I typed the function that I wanted and then I implemented it wrong, and now I do actually need to implement it in the right way.
Right.
Because I don't have tuples here, I have the tokens, right?
Right.
And that is that. So down here, that is an AST node, and that's an AST node, and that's not a make expression. It's just a thing.
Right. So it's you did. This is the way you wrote it the first time. Yeah.
Yeah. But then so where are we? So here, I need to put the make expression back in. So and so that's that, and that's that, and that, and
Is it that way around, or is it make expression of make tuple?
Oh yeah. Yep. Oh, for God's sake. You know what? I'll Rust format it in a minute, and that'll sort it all out for me.
Yeah, I spend my whole life just writing terrible formatting and just letting the formatter do it for me.
There we are, lovely. Right, so
what's it moaning about?
Where are we?
It still doesn't like you.
Oh no, because that's a test failure. It's marking a test failure.
Oh, okay.
So that's the operation, and that's so that's good. What's it complaining about here? Because that's an AST node, and it wants an option. Oh right, so I need to I need to sum and OK it, and I'll pull those out later. Okay, so it's sum because it's the results. It's okay.
Okay.
It's okay. It's fine. It's fine. It's okay. Arguments to method are incorrect. Love it. Okay. So why? No.
Prev is an option. No, next node is an option of result.
Okay. Let's just hate ourselves.
What could go wrong? Just unwrap it a couple of times, you'll be fine. Need one more, right?
To unwrap the result.
I think so.
So I've got the result and that, right, okay. Yeah, there we go.
Hang on, Prev still problems.
Because Prev is an option as well.
Right. Of a result.
Yeah. So this is very much lining up with my past. Can't borrow. Oh!
Yeah. All right. So now.
Okay. Now what is going on here now? Because I'm. This is starting to align a little bit more with my previous experience.
Right.
So what's going on here? Why is this problematic?
So you are calling self.operation.
Yes.
And one of the arguments that you're passing into self.operation
is self.
Well, it's not self. It's like the result of calling a method on this.
Yes.
And I think it must be that the return value from next node has some kind of reference to self still. Or otherwise, it would be all right. Like whenever I got a problem like this, I'll just move that out into its own line, right? The method call.
Well, none of this relies on.
Yeah, which I'm not quite sure.
So what if we just inline that?
But it's still going to be... Oh, I see what you mean. Okay, maybe.
I don't know. I'm stabbing around here.
There you go. Amazing. So, I think what we could have done is broken out the line where we're creating the argument into a variable earlier, and then at least the error messages would have been clearer, or we would have gone away.
Yes. I think. Let's come back. But I think I can probably sort some of this out because I'm getting too eager with the wrapping that I'm doing elsewhere.
Yeah, quite possibly.
This is interesting because I'm going to have to think about this because if we hit the plus and we haven't got a prev, that's an error.
Yes. You could actually match on
the previous, so then we could. Yeah.
You could, and if you wanted to, you could match on a tuple that you make on line 36, right? So you could say match open brackets token.0.adds comma prev.
Oh, yeah. So the prev has to be a sum, and anything else is going to drop off the bottom bit. Right. Well, let's. Christ, mate, we've been here a while.
Are you test passing?
No. Why not?
We're getting ahead of ourselves because it's nothing like what it's supposed to be, is it?
No. So that's his next expression. And then that goes to next node, which comes into here. And it's not even close. Why are we still getting the last expression?
So presumably we're calling this code on line 41, getting next node. Then that calls this one that hits a semicolon and returns.
Wait.
None.
It's not. It's not. That's the wrong thing. because this is going down too deep, right? This goes into next node, which goes into build node, which creates a next expression, which then recurses back in, hits the semicolon, and that's right. We just want to. Like,
oh, you mean you don't want to, but why doesn't this work? Doesn't that? Oh, because then we're expecting another semicolon.
Yeah.
Ah.
So we don't want to recurse down here. We just want to like peak the next or pop the next node or get the next.
Yeah, I mean, you could call just next token, right?
Okay. Yes.
You could call build node from here on next token.
Yes.
This is going to obviously need work when.
Oh yeah. But I think because I have gone quite wacky here, so we're going to do self. We're going to pull the next token. I'm going to. What's the question mark do?
Oh, it's so good.
Go on, tell me about it.
It returns immediately if this is none, or it returns immediately if this is error, depending what type of.
And that's an option, so I need to unwrap that. God. He said, no, what? Change type of parameter. RHS to AST. I thought I had.
What does make operation take? Does it take AST?
Yes, and that's okay.
Build node returns an option of AST, so you will need to unwrap it.
Yes. Yes. So expect AST found option. Oh, it's unwrap.
It's a double unwrap. Yeah.
Yes, the classic. Okay. Oh, and right. This is okay.
Okay.
No, that one.
Yeah.
So I can do this, right?
Yes.
Just pop it in here.
Yeah. I'm a bit surprised it's not okay with you doing this, actually.
Okay.
Hang on, did it? Oh no,
here we go.
Run a test, come on.
No!
Oh, still not working. So yeah, I still felt like our analysis was somehow lacking.
Oh, sorry, I just get my dogs off barking. Yes. Right.
All right. What I was saying was, I could teach you.
Go on.
I could teach you a debugging technique if you like.
Teach me.
There is a macro called dbg. So I was thinking we probably want to know what token.0 is. So maybe before this match statement, we could just say dbg exclamation mark ampersand token.0. Sorry, open bracket ampersand token.0. Ampersand token maybe. Yeah.
Just like that?
Like that. And then it will just print it out whenever it gets there.
Okay. Number 32.
Right. Operation plus.
Oh, you know what it is.
Yeah, we just did it wrong. Yep. We're smart. Oh, it passes. Oh, amazing. Oh, we've got
and on that bombshell.
All the hard bits were done.
Oh my goodness. Right. I feel like that's a slightly anticlimactic place to end after I had to run off and calm the dogs down because of my previous frustration and then had to get the headphones working again.
That's all right. I'll chop that bit out.
Just technical difficulties. Okay. Right. So if we have a look at that, that diff. So we've added the operation there with the opcode and the boxed AST nodes, which feels fine.
Yeah.
And the change here in next node, so that we separate, we don't just assume it's an expression, we start to separate out the building out. And I think I need to work on those names. Next expression is not, doesn't need to be a member even, does it? And then we've got this build node, which is frankly terrible, but I feel like that's where we should stop, because it's giving the shape to where we're going, where it's going to go.
Yeah. Yeah, and
I need to think about what, with the operation, what happens when we hit an operation when we don't have that previous, and what happens with an operation when we get a none out of the next. You know, where, because it's because we don't have that. I know I said that I do a lot of this stuff where we cascading sums and things, but with this, where we get an error at, I'm thinking of those in terms of quite block things. So this thing happens, and then this thing happens, and this thing happens, and they're quite kind of linear. Open the database, do the thing, do the thing, close the database, right? And if any one of those fails, you just bin up.
It's going to bail out. Yeah.
Here, where we're going, well, if I encounter this at this point, that's bad.
Yeah.
Error path out. If I encounter this at this point, that's good.
Yeah.
Continue in this direction.
Yeah.
And so I need to think about how am I going to find those and propagate those through? And I feel it's going to come out quite neat in the end.
Yeah.
But to even neaten what we've got here, to get rid of those, those unwraps. Maybe I shouldn't be passing in an option at this point. Maybe I should, all those things.
Exactly. Yeah.
I feel like this is a good place to stop because the shape is coming.
Yes.
And I need to just work on that.
And I think, we need to cogitate on like because the test that we've got that's failing at the moment
is that semicolon condition.
Is the fact that
so we've got to say, I've got this, and now I'm expecting this next token.
Yeah. Yeah. There must be something like...
There must be this thing.
The whole purpose of the semicolon is to make parsing easy, right? Because it tells you when to stop. So you just carry on until you hit the semicolon. So I feel like once we can express that, it's going to make this bit simpler.
Yeah. So we're going to... Boop, boop, boop.
Nice. Well,
right.
Thank you very much for hanging out with me.
No, thank you, mate. It's been, the time has flown by.
Yeah. Well, we do tend to gossip. Before we even started recording, we had quite a good gossip about like D and stuff like that. So.
In the green room.
Yeah.
So I will have a little think about this over the course of the next few days. And then, perhaps, if you'll allow me, I can come back and show you how I've progressed.
That would be awesome. I'd love to do another one. We'll see whether anyone likes watching it. But, no one likes watching the other ones, so it's got to be better than that.
Well, I mean, why do you think the numbers on my Accu Talks are so high, Andy? I just got them running in the background all the time.
Right, and as I said, I'll put like some links for your stuff in the description so people can find out more. But yeah, hopefully we'll be back with a bit more. Yeah,
because these explicit sums and these explicit unwraps are obviously smells.
Right, you want it to be a pure streaming pipeline.
It feels like, well, if I've got to unwrap the thing, then this is code that's all under my control, then I've probably wrapped it too early.
I mean, so definitely, if you actually unwrap, we've got a problem here. But sometimes you might need to check whether it's none. Say.
But if we're propagating, but maybe I don't need the option at that point. Maybe I don't know.
I mean, definitely. There's a lot more exploration that can be done here. Also, we didn't talk about question mark, so question mark might help us here as well. So we can come back.
Okay,
to that.
well, I'll investigate question mark. That's a very easy thing to Google.
Yeah. Nice.
Thank you, Andy.
Thank you.
I've had a lovely time.
Me too. This is my happy place.
In front of your chest of drawers with your big Rubik's Cube.
This is the Rubik's Cube graveyard. Those are the they're the broken ones.
It's a little bit poorly, isn't it? Oh dear. Is that because you're so quick?
Yeah, that's right. Yeah. Just
there was an incredible video on the New York Times, I think it was last week, the week before, of like a slow motion video of a speed cuber.
Wow.
And he does like a 5-second solve, and he does like 66 moves or something in 5 seconds, and he's like, "Well, I was a little bit slow." But it's just like it's incredible. It's incredible. But look, we're trying to finish, so I'll stop.
All right. Thanks a lot, and we'll carry on sometime.
Andy. Lovely. Thank you, mate.
Cheers. Bye.
Good night.